and welcome everyone. I'm Brett Dunstan from Mining Green, and today I'm speaking to Richard Bach, who's a Chief Technical Officer with BluVein. BluVein are developing dynamic charging technology to help with electrification of mining equipment, both underground and open pit. So welcome, Richard, and thanks for joining us today.
Yeah, thanks very much, Brett.
So just to start with, what's your background and how did you end up, working on the BluVein team?
Yeah, so I'm a electrical engineer, by trade per se. Working in the mining construction industry. I've known of the organisation Olitech, who I essentially work for, who owns the BluVein technology. I've known of them for probably 10 to 15 years, been somewhat involved in some of their previous projects, from probably more of a spectator's view. And, just like the things that they did with respect to removing, personnel out of the danger zone, which is, their core business. They work with explosives and work with mining companies to, make mines safer in general. So, yeah, really, liked what they did. They were, from an engineering perspective, they did sort of, very cutting edge sort of type development and, research. I suppose I first really started coming on board from the BluVein system when James, the managing director, contacted me, and he said I was working on a rail project at the time, and he said, "What do you know about pantographs and essentially electrifying underground fleet?" And my initial response was, "Stay away from it. That's something you don't want to get into." And my brain went straight to open conductor. So that about a month or two later, he called me in and said, "Oh, come in and we'll give you a bit more background of what we're looking at and one of our next projects." And that was BluVein. And he gave me a good presentation and introduced me to the partnering team over in called BluVein's over in Sweden, who owns all the core technology and have been developing their system for more commercial applications for the past 10, 12 years. I really liked, and the key difference there was that it was a sort of safe IP rated conductor, so overhead conductor. Something that I thought would be able to be adopted. So it was, for me, the buy-in was, would this be able to be used in the industry? I saw definitely some advantages there in bringing that on board. So we're talking, I suppose, when was it? Early 2021. It was when I came on board with full time with BluVein, and yeah, I've been here ever since.
You probably sort of covered it, but where the idea behind the BluVein technology and why it was developed. I suppose it came from BluVein's and working with Olitech and whatever, but how that sort of came about.
Yeah, so originally, I suppose, like, we're going all the way to sort of 2010 here, where the main developer created a company. So a guy by the name of Gunnar Asplund, based in Sweden. He developed or started thinking about, this electric car. So electric cars were starting to hit the market. They were really in their infancy. And he looked at that as, what is a way that we can get, more energy delivered to these cars while they're moving. So he developed essentially, or started trialing essentially a system that, safely connected to vehicles and dynamically charged, so charging on the go. And basically, over the past 10 years, has developed that into, a safe system compared to, an open conductor system. Being delivery onto vehicles was, very new. Obviously, the railway industry has been doing this for probably over a century. Trams and I suppose extending to buses, but from a vehicle sense, that's relatively new at the time. Even he said he was reaching out to the community, and a lot of people were saying that he was crazy and it'd never be adopted. And we're very much in the fossil fuels mindset, even 10 years ago. So that's probably the birth of it is really from Gunnar. He has to take a lot of credit for getting us to the place that we're in. I don't think that we certainly wouldn't be in the position we are without the work that he's done. Elway's, the name Elway's is now changed to Avias, and he's still a core member of that team, technical team, and we talk frequently about they very much focus on more commercial industrial applications, where we focus on mining applications here in Australia. So there is a lot of cross pollination between the two technologies, and we definitely talk very frequently about different ways and different things, and how we see the market changing, how we see our technology being adopted into those markets, and really focusing on sort of a simple solution. We've looked out in the industry. Our first research in the industry was looking out at how is this done before, and we have seen some of these in the 80s, you could say, for the Karuna truck system was something that we always go back to, because it was the first real dynamic charging type of a solution, or overhead pantograph solution in the mining industry. We saw that as an awesome Mark 1 dynamic sort of charge or overhead delivery system, but always were wondered why it never took off, and why it never met its Mark 2, Mark 3, and continued to evolve. I think the mining industry in general, those who were aware of that system, were of the same opinion and the same view. So we spent a lot of time with the mining industry when we first kicked off, to find out whether there was an actual market for it. We are a small company, so it's not like we want to invest. We don't have the budgets of the Volvos, the Epirocs, the Sandviks to invest huge amount of time and money into sort of sandbox type stuff. We need to find out whether it's real, see whether there's a need and value in the market for it, and we do that by our direct relationship that we've got with a lot of mining operators and mining partners. And we got a lot of feedback from them of why they didn't like say the Karuna truck system, but how it needed to be better. And we've based our requirements around how do we make that better, and how do we get to a Mark II version of an overhead delivery system for charging electric vehicles.
I think it's probably been quite an evolution over the years from initial concepts to what you've got now, with going underground and the open pit, and your different sort of solutions going there. So it's probably ongoing process. Is it pretty settled with it where the technology is going now there?
Yeah, definitely. We definitely started primarily focusing on the underground, in the underground space. In the early days, we steered clear of the above ground space, purely for the fact that we didn't think that we had a position in the market there. The Charge Joint Innovation Challenge came along. We, I suppose, agonised over a submission into that challenge for probably a couple of months, and that was really understanding that was going to be a lot of time and effort to put a valued submission in. We weren't sure whether when we're looking at differentiation in the market, whether that was a place for us. There was already overhead hybrid systems out there for those mines who wanted to go electric. The vehicles in the above ground space weren't I suppose up to the level where they are in the underground space. There's a huge range of different sizes of vehicles to play in the above ground space. And it was really that connection that we have with the industry that we talked to a few of our mining partners in the underground solution, and they actually came to us and said, we do see merit for your solution in the above ground space. So we discussed that with them, and then had decided to put a submission in, and ended up being quite successful in that submission, so the above ground space is in parallel, starting to really grow legs for us. So we're not only focusing on underground anymore, we're also focusing on above ground. But it's a whole different ball game when you're talking the size of vehicles in the above ground space.
I suppose it's a resourcing too. Like you're still a fairly small team, so you don't want to go and spread yourselves too thin.
Yeah, exactly. We're super cognizant of that. We've not. BluVein isn't our only project that we work on. We've got a number of other projects that are on the go in parallel. It enables us to be fairly dynamic, being a small organization. We're dynamic, we're flexible, we can move quite quickly, we can transfer people in and out of teams, quite effectively and efficiently. Everyone in the organization knows what's going on with different projects, and that enables us to get people up to speed quicker. We follow, I suppose, in the early days, we followed very much a project management style of delivery of projects, and we realised that after a short term that didn't work so well when you're working in the R&D space. So we started adopting the TRL, so technology readiness levels, 1 to 9, essentially 1 being I've got an idea, 9 being I've got a commercial solution, and that's really to step us through those progressive stages of development, so that we know essentially if there are issues, we can solve them as we move along, and we're not finding them, I suppose, at the end of the project. So a common saying is we're not building a fridge. It's something new. We're doing investigations all the time. We're reaching out to other partners all the time as well, and finding as much information as we can, so that we reduce rework and reduce the amount of time and effort that we spend on, I suppose, failed or flawed solutions.
How far along those TRL levels are you with the technology?
Yeah, so our underground position, we're in TRL 4 at the moment. So TRL 4 is all about integration. We're TRL 3, which we finalised end of last year, was really proof of concept. So we built what we call the pentagraph. We call the hammer. So we built a hammer so it could essentially connect through a guidance and vision system, so taking a lot of the control away from the owner. So very much the proof was, could we connect automatically? Could we connect on the go, so while this thing's moving, and would it be a reliable connection? TRL 3 doesn't, in that stage, you don't by the book, you don't have to build a full-scale model. But we chose to do that because we understood that would be more beneficial for a future development, and that's basically where we're starting in where we've started in TRL 4, is looking at that initial concept, the full scale model, and working out how to make that better. So it's not only proving, but it's also making the solution better, more efficient, obviously reducing size, costs, weight, etc. That'll help us get to market as soon as possible.
Right. Just want to take a step back, sort of a bit of a different path, but some of the benefits of BluVein compared to just sort of straight battery systems or the like. Why is it I suppose it's different technology, but why is BluVein beneficial?
Yeah, so we saw, I suppose, in our early investigations, we quickly found out in the underground space, players such as Epiroc and Sandvik had already created battery electric vehicles. There was a huge focus on fast charging and battery swapping at the time. We looked at those solutions, and while it was great to see what these organisations were doing, and how far progressed, and the foresight that they had. They'd already developed these vehicles before, long before, or started the journey long before we came along. But we were always concerned about battery swapping, understanding what mine operators required. They need robust haul cycles and reliable haul cycles. Being able to swap vehicles, swap batteries on vehicles takes time. May introduce more vehicles into their fleet, which is an additional capex and opex cost. So really we honed in on why do we need such a large battery source on board? How do we eliminate? We're all about eliminating the problem. if the organisations or the mining partners see, as in that battery swapping and the time it takes, and the fast charging and the increase in the overall network to deal with peak demand of fast charging, how do we eliminate those solutions? And essentially, it all boiled down to, well, we've got to deliver power to the vehicle while it's moving. So that's essentially, I suppose, the problem statement that we started off with was, how do we actually deliver this? Stop the inefficiencies associated with swapping batteries and reducing the costs of not only batteries, because you need, say, 2 to 3 batteries per vehicle as they're charging and as the vehicle is on its cycle. To how do we deliver that charge to the vehicle while it's moving? We quickly found out if we could do that, we not only reduced the additional batteries that are required, we could actually reduce the onboard battery as well. Looking at the costs of battery electric vehicles, the batteries are a huge component of that. Their weight as well. These things are sort of 6 to 8 tons. If we can, cut them by 30 or 40%, that's not only a huge cost saving, it's a weight saving. We could use that space that we've created for our onboard equipment. So there was a lot of benefits there, and it was all about finding the right solution. We knew we didn't want to go open conductor because that had been trialled before and wasn't broadly recognised as the right path either. And that's basically led us to, working with the team in Sweden, the BluVein's team. We really liked their solution. We saw that could be, adopted from more of a commercial, solution into a mining solution.
Yeah. And so, like the BluVein, you really have running on sort of your declines or your haul ramps coming up and up and down the pit or the underground. That's right. You wouldn't necessarily have it on levels on your flat sort of hauls. It's really about getting that, where you need the power going up. Yeah,
definitely. It's all about we still want to utilise the battery on the flats. We don't want to make this a pure dynamic charge everywhere. Everywhere on the cycle. But it's about taking out the biggest load area of the vehicle in the cycle. So that biggest load area is generally up the incline, fully loaded. If we can charge the battery as well as drive the traction motor, it takes a lot of stress off the battery as well. So battery life is extremely important. So with fast charging, that reduces your battery life. Essentially puts a lot of stress on the individual cells once you have cell failure and when you're talking about onboard vehicle batteries, they need such the battery doesn't per se fail. It just degrades to a certain level where it can be repurposed for other means such as storage and the like, but it's not like your car battery where you can run it till it's dead and then just swap it out. So it gets to a point where you've stressed that battery enough that you need to essentially remove it. It might still be able to be repurposed for other means such as storage, but we very much focused on if we can get instead of using 3 batteries on one cycle, if we could use, let's say, a quarter or half of a battery's, cycle, because they only have a set amount of, charge up, charge down times. If we could reduce that, we increase the life. We can sort of start doubling life of battery. Then, that relates directly into halving costs of batteries as well. So, we're very cognizant that the world is changing to very lithium-ion heavy style solutions for transport and e-mobility. The more and more we move to every household having electric car, the less lithium-ion there is out there. So there's only it again is a finite resource, and the rarer it becomes, the more expensive it becomes. So the ability to look after that resource on the vehicles as much as possible. There's a lot of companies out there looking at recycling as well and repurposing. I know the dealings that we've had with Epiroc, they're very much looking at batteries and maintaining that as a service, repurposing, recycling. One advantage of the lithium ion is that it can be recycled extremely efficiently. However, you do need the infrastructure to recycle it. So there's not recycling stations, everywhere at the moment, and there's a lot of technology development happening in that space as well. And then, it's making sure that the recycling of these batteries is done cleanly and efficiently. There's a lot of, ways to recycle that aren't, environmentally friendly, which is counterintuitive to what we're trying to achieve as well.
Yep. So, have you had any big challenges bringing sort of the technology to the market, getting it to the next level and where it can be used out there?
Yeah, so I suppose the size of the organisation we're at, we completely understand our place in the market. We're a developer. We're not a commercialisation, entity. That's not our core skill set. We use the mantra of standing on the shoulders of giants. So partnering is a huge part of our success, and making sure that we've got the right partners to deal with. So that once we develop this solution to a reliable level, and we're happy to progress to market, that we have the ability to leverage the organisations and the business units that they already have in place, and the knowledge and the know-how and the connections that they already have in place to be able to get to market. So we realise that we're not going to be the, at the end of the day, we're not going to be the distributors. But we need to make sure that we have the correct partners in place to, get that, product out there. Huge advantage for us in the BluVein underground project. We have a consortium consisting of 8 mining partners that are financially invested in the solution as well. So we that tells us that there's a market there. I suppose the biggest question we get is, when can we have it? Which is always a good problem to have. And we've just got to work through those development stages to get there. Being able to, create a solution and then, is one area, but getting it to market is completely different. And that's why we've leveraged, the work that we've and the partnering we've done with OEMs such as, Epiroc, Sandvik, McLean Engineering and Volvo, which are really the key players for us from OEM's perspective. We see them as the final, essentially users and adopters, and we need to take into consideration, their requirements as well. You completely understand they can't be, creating a bespoke vehicle for, BluVein. We need to be able to adopt into their vehicle. That reduces costs and enables, if someone wants to, have an open conductor solution, say from a Siemens ABB or the like, or whether it's a BluVein solution, it's still the same vehicle. So making it as easily and effectively to essentially buy a kit of parts, doesn't matter which solution it is, but making sure you have an interoperable solution there for the OEMs to be able to, and the mine organisations to be able to use for whichever solution that they see fit to use.
Yeah. So you mentioned like the 8-9 companies that are mining companies that are backing BluVein, like they're pretty keen to see the technology, get out on site. Yeah,
definitely. Like I said, we have weekly meetings with the currently 8 partners. We've had South32 just joined, so we had 8 partners in TRL3. We go by a stage process. So 8 partners in TRL3, in TRL4, South32 came on board. So there, we spent probably a little bit of time with them playing, catch up and educating them on what happened in previous stages of the project. But we're seeing, I suppose we have that problem that we're, I suppose, at capacity at the moment. More and more partners causes us more stakeholders to manage, and it's an additional reliance on our team to make sure that we're taking all the considerations from those partners. We have a lot of, we went through a stage in our early days in sort of 2001 to, really go out to market and I suppose sell the solution and market the solution and see what interest was out there. That completely changed mid last year, where the electric mine revolution sort of suddenly became the top of everyone's priority list from our mine operators' perspective, and all of a sudden it's probably one of the first times we've really seen the global mining community all move as one to, a final goal, to achieve a final goal. So, that happened quite quickly. As soon as that happened, we went from, selling to and educating. Education was a big part of our early discussions to, really, talking, getting the knocks on the door and getting the cold calls about, wanting to know more about the solution. Our presentations changed from educating to just informing, because people were already starting to educate themselves on all the different solutions that were available out there, and trying to figure out really how to go electric and the best ways to go electric. That really, stemmed out of 2030 targets set by companies, 2050 targets set by companies, and, developing internal sort of business units to, go out into the industry, find out what solutions are out there. And I suppose the industry is really in a position at the moment where I feel they're trying to find their feet a little bit as well. They're trying to see which horse to back. There's a lot of different solutions out there. And I suppose there's a lot of miscommunications around how successful some of these solutions, could be, or where they are at the stages in their development. We want to make sure that we're pretty honest in where we're at in our development and where we want to be. And, having, our partners on board from the mine operators, that really makes us, sets us up to make sure that we're open and honest with them about where we're headed. And it's really, working with those early adopters to start with to make sure that we develop a solution for their needs. We don't independently run away, develop a solution that just isn't viable for the industry.
Just making sure it fits the purpose of what it's being developed for.
It needs to be fit for purpose, definitely.
Yeah. So it sounds like, you've got your key, companies backing you, but like if you want, there'd be more if you wanted to stuff, but it's a balancing act between supporting them and actually just getting the technology developed and ready to go.
Yeah, definitely, and it's knowing when you're at capacity. We have, if you'd have told me in early 2021 that we would have had 8-9 partners backing us, I would have said, well, I think we might have 4. So having that, I remember the first call that we had. When we put the consortium together, essentially we got off that call and really looked at each other and went, "Wow, that's impressive." Having the likes of your BHPs, your Vale's, Glencore, Newcrest, Agnico Eagles, Oz, on those calls, all together was representatives from each one of those, all competitors, all working together to develop a solution, and that was probably the biggest surprise for me when I first started. It was that the mining companies were, less about competition and more about give us the solution. This is a problem. We don't care who we need to deal with and who we need to work with. Just get us the solution. And, that's, really, from an engineering perspective, that's a, really great position to be in, where everyone's sort of trying to push for the goal and not trying to sort of jostle for position per se.
Yeah, a bit more collaboration and less competition, because it's
definitely
probably plenty of space in the market for everyone. So yeah,
exactly. Yeah,
BluVein compared to other trolley systems, like what some of the big benefits, I suppose, it's compared to what has been done in the past. I think you covered it to a little degree, but
yes. So like open conductors, obviously I spoke about that earlier, but open conductors was always a concern. We knew that if we went with an open conductor solution, that's been tried and tested before. The mining industry, being, very safety conscious, just see problems with open conductor solutions. And it only works in certain situations as well, where essentially you've got a really long, straight, haul road. Trying to maneuver around switchbacks, etc., is quite, a concern for an open conductor solution. That's where we looked at our advantage over other dynamic charging solutions. And to be honest, there's not really many out there. So I think it's one of those things where the industry got caught, I suppose, a little bit deer in the headlights with, that's the way that the railway's been doing it for, 100 years. That's the only way that it can be done. So, that's where we look at things, I suppose, a little bit differently. And just because it's been done for 100 years doesn't mean it's the right way, to do it. And looked at different options around how can we do it. We're not about we need the solution isn't the final answer. It's the right solution is the final answer. So we've gone down the school of hard knocks of developing solutions in the past that we think are great, but then you go to industry and industry says, well, that kind of doesn't really work for us, or that's not how we do things. So making sure that we took on board the concerns that the industry had and said, well, that's really the requirements that we need to work around. What are the solutions out there that can meet all those requirements?
Do you think, is it far off being actually tested out on site?
Yeah, so we've so in TRL 4, TRL 5 is really our integration piece. So that's where we integrate into a vehicle. We've signed an MOU, which is public information. We've signed an MOU with Epiroc to supply us a vehicle for that test site. So they're underway, and we're having weekly meetings on that integration piece at the moment with Epiroc. So they're on board. They've invested a considerable investment to get us that vehicle. It's not like battery electric vehicles are readily available. They're definitely not readily available in Australia. So when you're talking about logistics and even just getting us the vehicle on site, that is a huge feat. So that's I suppose another gives us a hell of a lot of confidence that they see a company like Epiroc see huge value. They're ready to invest and make sure that we have all the components that we need. The vehicle is a big part of that to actually get to the trial site. So we're aiming trial site sort of Q1, Q2 next year. We're in the process of developing our trial sites at the moment, and working towards proving us at TRL 6. So that's where we do our development. For our first prototype. On an integrated vehicle. And then TRL 7 is our final adoption. So we're looking at a few different sites that, makes it easy for us to move from TRL 6, being, the real, initial test, to TRL 7, which is essentially a simulated in operational environment.
Right. That's a good show of support that they're willing to give you that piece of gear, because they're not cheap and they're not easy to get hold of. And I was speaking to the other day, is that one of the big challenges is the price and the getting hold of the equipment. So if you can get hold of one, then that's definitely big help.
Yeah, definitely. And we've got, I suppose, Volvo Epiroc are the, leaders in that space. We do have, the other companies that we're talking to, Volvo, Epiroc, Sandvik, are also in the midst of, looking at seeing what they can do for us from supplying us, vehicles. So we're all about being agnostic, making sure that we can adopt to multiple vehicles, not just one. But with the MOU that we signed with Epiroc, that gave us, a real confidence that we would reach our targets to get to our test site.
Hopefully, testing first half of next year. Like how if testing does go well, how soon do you think you'll be able to start rolling it out a bit more broadly?
Yeah, definitely. I suppose for us, we can move as much as the support that we get, as fast as the support that we get. So we've got really good support. Obviously, that commercialization space is probably which we get into TRL 8 and TRL 9. That's the space that is really, I see there's the unknown or the limiting factor as in deploying. We're working with the mining companies at the moment to look at their reticulation systems, seeing whether they're up to scratch to be able to, adopt as easily and effectively enough. We've got essentially 3 different scenarios when we're talking mining. We've got, green fields, which is, best case scenario. It means we've got a clean sheet of paper to start with for our development. We've got brown fields, which poses different problems around, integrating with an existing network and changeover of existing fleet. Which is going to be an expensive exercise. and satellite deposits. So the Caruna truck system was developed to essentially get to a satellite deposit, reduce the amount of ventilation required due to diesel emitters, and getting to those deposits. So those are the three scenarios we're really looking at, and part of our site studies that we're working with the partners on is really looking at how do we adopt into those three different mining scenarios. What are the costs there to upgrade your reticulation, or what are the changes that need to occur from drive development? And then really it's about our partners going away and looking at that feasibility around being able to deploy. And we're very much we're never saying that we're everything for everyone. There are different mine sites out there where fast charging, the battery swap solution, may be the right answer. We're not about saying that this is the way that the whole industry is going to go. There is different organisations that obviously are heavily backing hydrogen and see that as the way to go. So we are really all about making sure that we're developing the right solution for the right scenario. So when we get questions very, I suppose, generic questions, it's really a case-by-case scenario. We're also working with RPM Global on simulation around making sure that we've got the metrics from the OEMs in those simulation pieces, so that the mining companies have the tools at hand to start assessing it. Do we need a dynamic charging solution? Do we need a static charging solution? What is the best benefits for us? Because if it's not feasible, it's not going to be adopted. So we need to make sure that we focus on the feasibility and the right tool for the right task, essentially.
Yeah, it's definitely no two mines will be the same. So it's like being able to, it's almost tailing it site by site, like you said. And
definitely.
When you're talking electrification, a lot of mines, might be trying to reduce their declines because it is, harder to electrify. But that'll be hopefully, as long as you be out there on enough sites, that I'm sure make a big difference.
Yeah, definitely.
Recently, you saw that BluVein in one of the was it 8 winners in the Charge On Challenge. How was it being part of that?
Yeah, really interesting. Like I said previously, we didn't think that we really had a place in the market in the open space. It poses different problems with respect to size of vehicles or range of size of vehicles, and that has an effect on the power delivery ranges for those vehicles as well, which are problems that we didn't have as much in the underground space. Underground space, obviously, because of the decline size, you can only fit a certain size vehicle in that space. Declines are, the profiles are fairly common in underground mines. So, we knew what vehicles we had to deal with. We got to a final solution with respect to size of essentially capacity of the network and ability to deliver, a certain voltage and current to the rail from our power delivery sense. It was all in the above ground space. It's really, we're in the stages at the moment of working with the partners to figure out what is the power, what are the power requirements. Different mine sites have different vehicle sizing, ranging from say 140 ton all the way up to 360 ton. Different vehicle spacings require different loads on the rails. So we've really kicked off looking at some of those early problems and getting a baseline for the solution. Now, it could, the above ground solution could split into, we could use essentially the same technology to split into two different, sizings. It doesn't mean that we can just go into the CAD model and press enhance and, we've got two different size models, but, or two different solutions there of different, power delivery sizes, but, making sure that we've got an understanding first of what the requirements are, so we can define our specific development requirements. So we're very heavily requirements focused. We need to get that right at the start of of our project development to make sure that we don't, reduces our rework along the way. Whenever someone comes along with new information halfway through your projects, it's always fraught with danger. It does happen, and it happens a lot. But it has an opportunity to completely change the solution. So we're treading, I suppose, very carefully. Given that we're above, essentially, we're venturing into HV, so high voltage delivery poses a whole set of challenges and risks associated with being able to deliver HV to a vehicle. But, definitely not insurmountable. And we definitely see an opportunity there with it's more of a side mount solution rather than an overhead solution. Reduces on infrastructure, reduces on costs, makes it more flexible to move to the sites. When we first started, we didn't realise how flexible the sites had to be, how often they changed their haul roads. If they needed to get a big shovel down to a certain location, they couldn't use the same haul road as their dynamic charging solution because of the overhead lines and the potential to strike those overhead lines. So, we soon figured out that working with our partners in the Charge on Innovation Challenge and the patrons in the Innovation Challenge, that we could supply some really good solutions and some innovative solutions around that. And I suppose they saw that before we did, to be honest. And that's the reason why we're still involved today.
Yep. So it is. So BluVein can be sort of, modular in a way where it can change and adapt. It's easy to sort of take sections out or something like that to be able to modify if you have haul roads or whatever changes.
Yeah, definitely. And that was really the Vias team over in Sweden had developed that for their sort of commercial solution. And they looked at it from a sense, well, if we're installing, rail in public roads, we can't shut the road down for 3 months while we're installing this. This needs to happen on night shifts, and, we need to be quick and efficient. So part of their design was essentially, long sections of rail where that could be brought to the work front on, say, a flatbed truck, craned off, put in the ground as quickly and efficiently as possible and moved on. So they were all about kilometres of delivery per shift, which, really carried into our design development as well. And that's sort of where we started as well, knowing that we can't stop a mine's operations for 3 months while we deploy the rail. We need to be able to integrate with the mine operators and, work out sort of specific shift times and the ability to work in with them to deploy as quickly as possible. And that's where we focus on, the modular, a modular style system, removable, relocatable. Essentially, everything's in a confined rail. Essentially, unbolt, relocate, rebolt. Even looking at footings, support infrastructure in the above ground space, how we can, how we can reduce the amount of, I suppose, digging that's required for those footings, and being able to, fix that, civil infrastructure per se and structural infrastructure in place so it can be relocatable as well.
Yep. No, it's definitely, good to see, because it's probably, asking for trouble if you did make it sort of one long ribbon, so to speak, that, you have an issue whether on one part, or if you change the route, then it's just going to be it'd be a major headache. So if you can make it so it's modular like that, it'll definitely ease implementation and any maintenance and all that, those sorts of issues. So so I suppose now you're really working with those patrons to get it to the next step, in the open pit side of things, and it is interesting because it is like an order of magnitude bigger, going from like 50-ton trucks underground to 200-300 tons. That I suppose it's how much power can you deliver down that rail, and to power that along. But yeah,
exactly, and it's that's where we like focusing on. Let's get that requirement of what's the power required and delivery, because everyone has different mine sites. It's very bespoke depending on what your operations look like. From haul cycles perspective, that starts from a reticulation. We see in this area fast charging once again as the requirement for your reticulation is going to be so big as well. Fast charging will increase the peaks on your articulation that are required on site. So being able to reduce that, reduces costs. And the ability to get power. We're having all sorts of issues around with power at the moment in Australia. From a suburban sort of retail sense, a mine site coming and saying, I need an extra, 10, 20 megawatts delivery to, my site in whether it be the Pilbara or central Queensland, the capacity just may not be there. So there's a lot of infrastructure that needs to be built and to make sure that capacity is available and reliable.
Yeah. So just knowing how big the fleets are and how much power they need, and then you go, oh shit, can we actually deliver that much power?
Yeah, exactly. You ring up the network provider, and for love nor money, that's not happening quickly. So there is definitely organisations out there that we're dealing with that are focused on that. They see that as a big problem in their place and their solution. Their ability to provide that knowledge and know-how and opportunity to solve some of those problems.
And I suppose rolling it out open pit would be, seeing how you go with the underground trials, and I'm sure that your patrons you've got there are pretty keen to get it out, but it'd be sometime in the next couple of years, but it's really, see how it develops on these TRLs.
Yeah, definitely. And it's not like where they've got, 360-ton battery, electric vehicles coming off the production line either. So we're looking at that as very much a staged approach. We might go hybrid to start with. If we reduce, let's say if we start reducing everyone's emissions by, 30, 40%, that's a huge success. That's everyone's target by, 2030. So that might start off as hybrid. We're not saying that, the above ground solution is going to be battery electric. We're sort of focusing on, there will be a fuel cell of some sort, whether that, hydrogen, takes over in the above ground space, and, you need a large amount of electricity to create, a hydrogen cell as well. So just because you've got hydrogen, electricity doesn't go away. Hydrogen uses electricity, but it's less efficient. So we also have the mantra that if you've got electricity available, just use it. Don't make it less efficient and then use it, deliver it to the system. But that being said, if we're going to, green solutions, wind, solar, they are unreliable. They don't, solar, obviously you need some storage if you've got nighttime operations. So, we do see, things like hydrogen or other technologies as potential, energy sources to keep that or to level out, the power requirements as you need them, in the downtimes for if you've got a large solar farm feeding your site, well, you're going to need some storage for night. So we see that as sort of more, potential above ground sort of power solution for storage rather than, direct delivery into the vehicle as well.
All right. No, that all sounds good, but I think that's pretty well all I've got. We've probably covered a little bit more than I had on my initial list, but no, thanks for your time and all that. And I just, any last comments you have? I think you probably covered most stuff, but anything else?
No, I think I've spoken enough. No, it was thanks for inviting me along. It's a topic that we've seen huge interest in over the last sort of 12 months, and I suppose continue watching our development, and hopefully we can start getting some good meter out there with regards to our trial site next year, and the work that we're carrying out with our OEMs, and then the work that we're carrying out in the open pit space.
All right, no worries. Thanks for your time today. Cheers.
Too easy. Thanks, Brett. Cheers.
Thanks for tuning in to Mining Green, where we share inspiring stories of how the mining industry is leading the way to a net zero future. Don't forget to subscribe down below, and please feel free to leave any feedback you might have in the comment section below. Until next time, see you then.